Okay, I think we can get started as people kind of continue to come in. So, hello everyone. It's great to be here again with you in the October edition of the Ask Tom series on graph databases and analytics. And today we're very excited to talk to you about our newly released Python API. So we have been running this Ask Tom series since early this year. We've done a number of sessions on like introduction to graph databases and analytics. We've done sessions on graph queries, graph algorithms, and some sessions focused on specific industries like the financial services industry. If you haven't yet, please do visit our Ask Tom landing page to see archived sessions and also announcements for upcoming sessions. And I'm joined here today by my colleague Ryota. We are joining you from different uh, parts of the globe. So I will just do a very quick recap of graph analytics. This is just in case you haven't had the opportunity to listen to earlier sessions, and cover just a few basic operations on getting started with the Python API. And then my colleague Ryota will go into some very interesting demos using Python to work with graphs. So the quick recap. So the Oracle database has a graph feature which allows you to store, manage, query, and analyze graphs. We support both the property graph model and the RDF graph model. The focus in today's session is the property graph model. So the graph feature is built on the enterprise capabilities of Oracle database. So you get the advantages of the manageability, the security, high availability, and so on when it comes to graph data management. In addition, the property graph feature has an in-memory graph server that allows you to load a graph into memory and run the compute-intensive graph operations in memory in a server that is specially designed for parallel graph operations. So this enables us to scale to very large size graphs, tens of millions of and billions of edges and vertices. The property graph feature also includes a graph query language, and this is a SQL-like query language. And by that we mean we have the SQL-like constructs like select from a graph, where clause, order by, group by, and so on. And in addition, we have a match clause for specifying graph patterns. Because when people want to query graphs, they want to specify graph patterns. So this language includes the match clause, and you'll see some examples of that in the demos. And we also, another key feature is that we support over 50 pre-built graph analytics algorithms like PageRank, identifying paths, identifying clusters. So these algorithms are pre-built and you can use them in your application by simple API call, which brings you the ability to run very powerful analytics algorithms on your data. And the feature also includes a lightweight visualization application that can be used from your browser to run PGQL graph queries and visualize the results as a graph. So we have a variety of tools and APIs that you can use to work with graphs to do the queries and the analytics and so on. What we have now is the Java API, or what we had till now is the Java API primarily, that can be used to run graph queries and graph analytics. For instance, here you see an example where you have a simple PGQL query, and here you're calling the PageRank algorithm, and these are run in the graph shell that is a JShell UI. And you can, of course, use these APIs in your Java application. And we also have an integration with Zeppelin Notebook. So we have interpreters available to work with Zeppelin Notebook. So we talked about the Java API in earlier sessions. And the Java API runs both against the in-memory graph server. So when you loaded the graph into the in-memory graph server, also known as the PGX server, you can run PGQL queries and graph analytics against the graph in the server. We also have an option of running PGQL queries in the database. For customers who don't want to stand up a separate graph server and who are not interested in analytics, they can run their queries in the database. And the Java API supports that as well. And what we are announcing now and what we've released now over 10 days ago is a new Python client that was released with the Oracle Graph Server and Client 20.4 that allows you to run PGQL queries and the analytics algorithms in the in-memory graph server. And for completeness, we've also had some integration with tools like SQL And SQL is a tool to run SQL queries against the database. It now has a PGQL mode. You can enable PGQL mode and then run graph queries. And this is one way to use a tool to run PGQL queries against the database. So the focus here today is, of course, the Python API, which allows you to run graph queries and graph analytics against a graph that is in the in-memory server. So why Python? So far, our Graph API is very popular with Java developers. And for database developers, we have the SQL tool, and also we have designed the PGQL query language to be as SQL-like as possible. We wanted to now enable data scientists to easily work with graphs and to help them integrate graphs easily into their current data science tools and environments. So if they're working with any Python client, it is very easy to connect to a database, create a graph from tables in the database, and put this graph in the in-memory graph server, that is PGX, and then start working with the graphs, querying the graph, analyzing the graph, and so on. So you can easily integrate graphs from data stored in the database into your data science tools and applications. So just a few more details about the Python client. The Python client can be used interactively, just like JShell for the Java API. We have a Python shell, or you can import a module into your Python application. And if your focus is on using just the database, and if you don't want to use the in-memory server for queries, you can, of course, just use the SQL tool and PGQL to run graph queries in the database. And if you want to use analytics, and for analytics, we do recommend that you have the in-memory graph server, you can then use the Python API for loading the graph into PGX and running your analytics there. In other words, the Python API can coexist nicely with other components we have. So this, the interactive shell, like you would, if you have used the product, you would know that we have the OPG JShell script that starts up the shell UI, and you can use that when you're using the Java API. You start that up, you connect to the graph server, and you authenticate yourself as a database user. And this is something new as of 20.3, that you authenticate yourself to the graph server as a database user. So this improves the security of the graph server, and we're continually improving security when it comes to this feature, and specifically the graph server and how it interacts with the database. And similarly now with the Python API, you would run the OPGPY script to start up the shell and connect to the graph server and authenticate yourself as a database user. And as I was saying, we have the Zeppelin notebook, which works with the Groovy syntax, and we have interpreters that you can use to install with your notebook and use to run PGQL queries and graph algorithms. And with now the Python API, you get support with to use the Jupyter Notebook. And no additional interpreter is needed. You just have to install PyPGX in the notebook server, and it then opens up the use of Jupyter with graph queries and graph algorithms. So let's just now take a look at some of the basic operations. So to work with the Python API, you need to have Python version 3.5 or later, and Java JDK 8 or later. And the installation is quite simple. You download this from it's part of the Oracle Graph Server and Client Kit that is available on oracle.com, and also on eDelivery. It has a number of components, and one of the components is the Graph Client component. And you install the client component, and you might need this additional component as well. And so the install is pretty simple, and you can very quickly get started with your with using your Python client. And once you have that set up, you can then connect to the graph server using the interactive shell that we were just looking at, and authenticate yourself as a database user. And once you're connected to the graph server, you can start running commands to create your graph. For example, you can use the PGQL DDL syntax, that's a create property graph syntax, where you specify your vertex tables and your edge tables from tables in the database. So you create your graph from these tables, and this graph is created right in the in-memory graph server. And then you execute this PGQL DDL statement, and then you have your graph, and you can start working with it. And if the graph is already has already been loaded into the graph server, you can get a handle to the graph using the get graph API. And then you're ready to start running queries. And here's an example of a simple PGQL query that is that you're running using the Python API against a graph which is in the in-memory graph server. And then finally, here's how you would run the analytics algorithm. So PageRank is just one of the, I believe, 58 graph algorithms that we have today. You can run the clustering algorithm, SEC Kosarajo, you can run between centrality algorithms and so much more just by making a simple API call. So now that we've looked at how we can get started, let me now hand over to Ryota to look at some very interesting demos. Over to you, Ryota.
Thank you, Mary. Okay, let's look at some demos to see how Python API works. Firstly, how to convert and load data from database. As always, I have already uploaded all the sample scripts and Docker files on my GitHub. So you can clone my GitHub repository and download the latest 24 packages so that you can build and start the Docker containers to try all the samples. The first example is to use a public dataset called online retail dataset from Kaggle, which includes 4,000 customers and 3,000 products with the relationships between them. They are like purchasers relationship between them. And we like to create a graph using that data set. So when you need you need this graph to analyze the customer and generate recommendation. Your graph should contain, of course, customer entities, node and product entities, and purchase relationship, so that you can see. Where's my mouse? Yep. Maybe using this graph, you can create the possible link with these red dots. These are the possible recommendation for those customers. So for creating the graph from the CSV file format data, you can upload the CSV data into database, and using create property graph statement, you can load the data and convert into graph on graph server. This create property graph statement has two parts. One is vertex table part, and another one is edge tables. And obviously, vertex tables part is defining the vertices. One is customer vertices, and another one is product vertices. And the customer vertices are coming from customers table, and it also includes country ID and customer ID and country as properties. Edge tables part also has one edge whose label has purchased. So this is a relationship between customers and products. And this information is from the table called purchase distinct. Okay, let's check the database first. I have uploaded the CSV file into this database. So this is one large spreadsheet which contains the ID of products and the description of products, also customer ID here. So this, which means this customer has purchased this product before. To convert this table into graph, we can normalize this graph into customers, products, and purchasers tables. So this is a customer table with the customer ID and country column. And also product table contains product ID and description. And this is a relationship table called purchases table. So it contains product ID and customer ID. Then we can load this graph from using Python API on Jupyter Notebook. So opening online retail notebook here, you can firstly connect to graph server from Python client. Then you will get the session ID here. This is the create property graph statement you run. So this prepare PGQL and execute method is now running the create property graph statement, which means the graph server was loading the data from database and it is completed. So now you can see the graph variable refers online retail graph with 8,000 nodes and 500,000 edges using 10 megabyte memory. So you can now run PGQL queries against graph server. So this is a simple PGQL query to get 3 products and their description like this. And also another query, this is getting the customer and property relationship for the specific customer 12353, which means those 4 products were purchased by this customer before. Something like this. So we can run queries against the graph on graph server using Python API. So now we did this command to get online retail graph, which were expanded on graph server, and then tried some PGQL query. So now you can also run graph algorithms. Here for calculating the recommended product for specific customer, we use personalized PageRank algorithm. So firstly, we like to get the vertex object for this customer ID. And then against this vertex object, you can run personalized PageRank. and the result is can be stored into a node property called PPL in this case. After running the algorithm, the results are stored into the graph as node properties. In this case, the property called PPL of all nodes of this graph. So you can access the results using PGQL queries like this. Then you can also visualize the algorithm result. For example, in this case, we often visualize the scores with the size of nodes. So let's see how it works. So coming back to this same notebook, we can now run the query to get the vertex object for this customer. And then against this vertex, you can run personalized PageRank algorithm. And it doesn't take much time, but now the graph has got the result of this algorithm, which means I can get the recommended product for this customer by this PGQL query. Yep, this query is basically getting the list of products sorted by the PPL score. So the first one should be recommended first to this customer. Okay, let's see how we can visualize the result. To log in to this graph visualization, because you would like to access the same graph, you can use this session ID to log in. Then you can find the list of graphs. And now you can see online retail graph, which were loaded from database. Okay. And yeah, putting the highlights, you can find the blue node is one customer, and those green nodes are products bought by this customer. So let's check the recommended product for that specific customer on this visualization. Okay, here you can see this customer now we are looking at, and this is those purple products, the one bought by this customer, and this yellow one is the recommended product for this customer. Because those nodes has already got the PPL scores, which are calculated by that algorithm right now. So you can change the size of the nodes according to the score. Here you can choose PPL score and change the size according to this score. Like this. Okay. So now we saw that we can create a graph from tables and run graph query and graph algorithm via Python API. Also, many customers and many users of Oracle Property Graph combining graph with machine learning. So let's see how it works. So this picture is showing how graph enhances machine learning. Because information coverage of the input training data set for machine learning algorithm is very important to make good prediction model. So the data scientists often create new engineered feature from the existing information of the entities. And the idea is that we can use a graph queries and graph algorithms to create more features. So now you have a table data set, but often the relationship information is not really reflected to the features of machine learning input. So you can create a graph view first, and graph view, of course, have all relationship information between those entities. So based on those relationship information, you can run graph queries and algorithms to create those new features. And maybe those new features can improve the prediction model. This is one example of the usage of graph with machine learning in financial industry for detecting mule account. Mule accounts are fake accounts, often stolen accounts, and transfers money illegally. And the question is it possible to generate more features based on the relationships information between accounts, such as transaction information and family relationships, etc. Because the original information of the bank account itself is like just a name of the owner and branch and balance. They are not sufficient for making the good prediction model. So we would like to add more generated features using graph queries and algorithms. One example is using graph query. We may be able to find whether those accounts, actually the owners of the accounts are sharing some personal information such as telephone number and emails. And maybe these are the indicators to find whether those accounts are suspicious or not. Another feature could be generated by a community detection algorithm, such as strongly connected component. Then we might be able to find whether those accounts are included in the same community which have many fraudulent accounts. And also, we might be able to use personalized page rank algorithm to find whether those accounts are close to the known mule accounts, because this algorithm can find the closeness between those accounts. Then finally, if we can get the more features, maybe these are variable for improving the machine learning. Okay, let's see another notebook called mule account detection and see how it works. Again, connect to the graph server and another session ID here, and get the graph, which is already loaded. Then you can find the owners of the account. A refers account and C stands for customer. So you can get the owner's name using this query. And at the same time, you can write this result back to the nodes, account nodes. So let's say account A01 is owned by Alice. Then we can also create a new node property on account node. Then update account node using the name of the owner. So now your account information can have new property owner. Using the same PGQL update, the next question is if the owner of the account is sharing personal information with others. So this pattern matching is showing whether those accounts A1 and A2 are owned by C1 and C2, and those those owners are sharing some objects. Then you can count the objects, the number of objects shared. Then again, you can write the information back to the account node. So the account nodes are enriched with new information called share info. The second property we would like to add is whether and how many, whether those accounts are in the same community or not. To do so, we can filter by money transfer edge only for calculating the community using strongly connected component algorithm. Then you can get a new feature called component ID and find that A1 and A2 are in the same component. Finally, using personalized PageRank, we can calculate the closeness from known fraud account. So you can get a fraud account and run personalized PageRank to get a new property called PPR. So you can find that A01 is known mule account, and A02 is close to this account. So let's check what happened on this graph on visualization. Again, you can use the session ID to access the same graphs and updated graphs as well. So you see a mule account original graph here. Let's add highlights for fun. Okay, this is the original graph of mule account network. And this is an heterogeneous graph. So you have owner node as well as telephone node and of course account node. Then you can find that these account nodes do not have much information originally. But using the relationship information, we have added some features. So if you go to the updated graph, which is also filtered by transfer relationship, you can find that those accounts have got a few more features like PPR, community, and share info. So now you can see that the account nodes are enriched, and such information can be useful for the input of machine learning. So for using the data for machine learning input, you can query to get the result into this result set. And then this script is to store the results into pandas data frame. Here you can get you got a pandas framework, which can be used for machine learning input using any sort of machine learning packages. Okay, then so now we saw that using Python API, we can create graph from table format data source, and then we can run PGQL query and graph algorithms to get more information from relationships. Then we can export the data as Python data framework for the latter process for machine learning. Okay, that's it for this session.
Well, let me just ask whether folks have any other questions. So some questions have been coming in, and I've answered them. And if you have any other questions, please do post them in the Q&A, the Q&A panel. And I just want to highlight again, in response to a question, I did post links to live labs, and that's an easy way for you to get started with the technology. You can get an instance on the cloud and run through a couple of labs that we have. And of course, Ryoto said that these particular examples are available on his GitHub page. So thank you very much, and thank you for joining us.
Yep, thank you, everyone.